Hey guys, welcome back to SUNA Academy. If you're new here, myself Karthikeya, I'm your physics tutor. So I'll be teaching you concepts of physics that are related to JEE Mains, JEE Advanced, NEET, UG and many physics Olympiads that you'll be coming across in your grades 8, 9 and 10. So if you haven't subscribed to our channel, do subscribe to our channel and hit the bell icon right beside it. Do like our videos and share our videos to your friends and your fellow aspirants. So let's get into the video. So the first chapter I'll be picking up for you in this series of videos is the chapter vectors. Okay, so let's get into the basic idea of vector. Okay, so let us get to know the difference between a scalar and a vector. Okay, let me take a block of mass 1 kg and let me also consider a block of mass 2 kg. Okay, when I'll be putting these two blocks in a system, okay, block of mass 1 kg and block of mass 2 kg, the net mass of my system would be 3 kg. So here you are actually adding both masses directly, okay, when you're considering the whole system, and you say that the net mass of the system is 3 kg. Okay, now let us take a different case where I'll be having a block, okay, and I'm going to apply a 4 Newton force on it. Okay, 4 Newton force on it. Simultaneously my friend will be applying other 4 Newton force on it. Okay, so now what is the net force on the system? Now here we'll be getting into two cases where I said I'll be applying 4 Newtons force on it, but I didn't say in which direction I'll be applying. Okay, let us say in the first case where my friend and I will be applying the 4 Newton force in the same direction. This is by me and this is by my friend. So the net force on this block is 8 Newton, right? And in second case, let's say I and my friend do apply the force on the block in opposite directions. Okay, I apply towards right and my friend applies towards left, and the net force on this block would turn out to be 0 Newton. So here it's in motion, the block is in motion, and here the block is at rest. So what is the what is driving to you to sort out these two cases? It's because that I haven't mentioned the direction in which the force was applied. You see, this particular physical quantity, the physical quantity which is known as force, the particular physical quantity, if I'm not going to mention the direction, it is going to sort you out into two cases. So if any physical quantity which actually depends on the magnitude of it, okay, so 4 newtons does matter, okay, if it is 5 newtons, the net force on the block will definitely alter. So in the same way, the magnitude, okay, when a physical quantity is actually depending on magnitude, and it is also depending in the direction which we apply the force, okay, direction in which we apply force, that physical quantity, okay, these two conditions are simultaneously satisfied, that physical quantity is known as a vector. Okay, and some physical quantities which only depend on magnitude, okay, which only depend on magnitude, but they are irrespective of direction. Okay, in this particular example, okay, they are irrespective of direction, so that physical quantity is known as a scalar. So now let us get to know what is the meaning of the term magnitude. Okay, so what does magnitude mean? Magnitude mean that the measure of some physical quantity. Okay, you say if a block is moving in some 4 meter per second speed or velocity, okay, velocity, then what, irrespective of the direction, is it traveling towards your right hand side or left hand side, or is it going up or down? Okay, irrespective of direction, even if it is negative, okay, even if it is negative, the net magnitude of velocity of the block is nothing but 4 meter per second. And do remember that magnitude is always greater than or equal to 0. It can be 0 or it can be, it should be only positive. Okay, never magnitude is less than 0. That is, never magnitude is negative. Okay, this is the basic idea of magnitude. Now let us see what is a vector. Okay, a vector, okay, if this is O and A and I represent this as some A bar, and your A bar means that your A bar is nothing but magnitude of A into A cap. Okay, what is A cap? A cap is nothing but unit vector. Okay, now first let us try to learn what is a unit vector. Okay, so unit vector is nothing but a vector which has got a magnitude of 1 unit. Okay, magnitude of unit vector is always 1 unit. Unit vector is always 1 unit. Okay, and it actually decides the direction in which vector is directed. Okay, so you see this vector a bar is nothing but magnitude. Some vector is always dependent on magnitude and direction. Okay, so mod a represents its magnitude, okay, and a cap represents its direction. Okay, let us take a 15 centimeter scale, a regular scale. What is one single unit on it? 1 centimeter, right? So similarly, if you have a vector, okay, if you have a vector and 1 unit of that vector is nothing but and in that direction, okay, if this is my vector and 1 unit of this vector and which is directed in this along the vector's direction, okay, along the vector direction, this is known as a unit vector a cap. And you can also simply say that your a cap is nothing but a bar by mod a, right? A bar by mod a. Now let us get into the term magnitude. Okay, how to find a magnitude of a vector. If you have a vector, okay, which is actually written in general like xi cap plus yj cap plus zk cap, okay, and your magnitude of a bar is nothing but, if this is your a bar, and your magnitude of a bar is nothing but root over x square plus y square plus z square. Okay, this is how you find the magnitude of that particular vector. Okay, and how is this vector actually formed? Okay, so let me get into the basics of forming that vector. Okay, let us take the 3D 3-dimensional coordinate axis. Let us say this is your x-axis. Okay, let us say this is your x-axis, this is your y-axis, and this is your z-axis. Okay, and I cap, j cap, and k cap are unit vectors in the direction of x-axis, y-axis, and z-axis. Okay, one unit vector along x-axis is nothing but I cap. Okay, and unit vector along y-axis nothing but your j cap, and unit vector along z-axis is your nothing but your k cap. So unit vector along x-axis mean it is a vector starting from origin, okay, starting from origin to 1 comma 0, and this vector, okay, this particular vector is I cap. Okay, and one unit along y-axis, that is 0 comma 1, sorry, since it is a 3D Cartesian plane, this is 1 comma 0 comma 0. Okay, and this point is nothing but 0 comma 1 comma 0. Okay, your general coordinate in 3D plane, 3D 3-dimensional axis is x comma y comma z, right? So and if any vector along z axis and one unit of that vector is unit vector, and that is k cap, and this will be tending from 0 origin to 0 comma 0 comma 1. Okay, so if I'll be saying 3 I cap, so 3 times multiplied 3 is multiplied to I cap, right? So 3 units of I cap means there is a vector which is starting from origin to 3 comma 0 comma 0, right? And this is nothing but 3 I cap. Any vector starting from origin along the z-axis, and if it is moving to 0 comma 0 comma 2, then this is nothing but 2 k cap. Okay, so combination of such vector will obtain any vector like xi cap plus yj cap plus zk cap. And here I also want you to know that if this is the case where I'll be considering, okay, and I have a vector which is actually starting from origin and tending towards your negative x-axis, okay, tending towards your negative x-axis, okay, and this point would be minus 3 comma 0 comma 0. Then you see that when this was your, if a vector was still 3 comma 0 comma 0, this was your 3 I cap, right? And if a vector is exactly opposite and tending to minus 3 comma 0 comma 0, this is minus 3 times multiplied with your I cap, right? So unit vector along negative x-axis is always minus I cap, okay, and it is 3 units, right, from origin. So this will be your minus 3 I cap. Okay, and you can also say that if this is a vector a bar and if the direction of this vector is exactly reversed, okay, if your final vector is turning out to some a dash bar is turning out to be this, and this a dash bar is nothing but exactly negative times the a bar. Okay, hey guys, if you haven't liked our video, do like our video to support and encourage us. Now let us also look into a question. How do you find a unit vector? Okay, if vector is given. Okay, so let me say I have been given a vector a bar is equal to 2 I cap plus 3 j cap plus 4 k cap. Okay, and this, if this is your vector a bar, then unit vector along this vector is what you are asked to be find out. Okay, so what is the a cap of this? How do you find your a cap? So your a cap is nothing but a bar by mod a. Okay, and your a bar is nothing but 2i cap plus 3j cap plus 4k cap. Okay, 2i cap plus 3j cap plus 4k cap by mod a. Mod a means if you have a vector some a bar equals to xi cap plus yj cap plus zk cap. Okay, and your magnitude of that particular vector is nothing but root over x square plus y square plus z square. Okay, so similarly here it's 2 square plus 3 square plus 4 square, and this will be turning out to be root 29. So 2i cap plus 3j cap plus 4k cap upon root 29 is the unit vector of a bar. Is that understood? Okay, now we'll be proceeding for the next question. Okay, now we'll be looking into this question. Calculate the value of r if p bar is a unit vector where p bar is 0.3 i cap plus rj cap plus 0.4 k cap. Okay, so what does unit vector mean? The magnitude of such unit vector is always 1. So mod p bar is always 1. Okay, so what is the magnitude of p bar? That is 0.3 whole square, yeah, plus r square plus 0.4 whole square is nothing but your 1. Okay, so your 0.3 whole square plus 0.4 whole square is nothing but 0.09 plus 0.16 plus r square is 1. Okay, so your r square is nothing but 1